In Lesson 3-4, we will discuss exponential and logarithmic equations. In video 3.4.7, our learning target will be for students to be able to solve logarithmic equations. In example 7, we're asked to solve the logarithmic equation log of x plus log of x minus 3 equals log of 28. Now, we can do this by using the one-to-one property we discussed in, I think, video 3 or 4, by getting a single logarithm on both sides. So if you notice, we start out with two logarithms on the left side. I can get that down to a single logarithm by applying the product property of logarithms, which states that if you're adding two logarithms, we can condense them by, when you're adding, we would multiply our inputs. So if I multiply my inputs, which are x and x minus 3, I would get log of x squared minus 3x by multiplying x times x minus 3. And the other side is just going to stay log of 28. Now, what happens here is that when we get down to a single logarithm on both sides, as long as our base is the same, which in this case it is, it's common log on both sides, or base 10, right? We have base 10 here. So those cancel out. Our logarithms would cancel out then, and state that x squared minus 3x is equal to 28. Now, what we can do is move all the terms on the same side. So I'm going to subtract 28 from both sides, and I get x squared minus 3x minus 28 equals 0. So we're going to go ahead and solve this quadratic equation by factoring, if it's possible. And I know x times x gives me the first term, which is x squared, and I want to find two numbers that multiply to be negative 28. Well, since my product is negative, I know I'm going to have a plus or minus, a plus and a minus rather, and I need to find two numbers that multiply to be negative 28 that add to be 3. Well, 7 and 4 multiply to be 28, so I'm going to say the 7's negative and the 4 is positive because they have to add up to be negative 3, and positive 4 and negative 7 add to be negative 3. Now, using the zero product property, since x plus 4 times x minus 7 equals 0, that implies that x plus 4 equals 0, which means x is equal to negative 4. And it also implies that x minus 7 could equal 0, or that x equals 7. So we have two solutions here, negative 4 and positive 7. And we have to go back and check our solutions here and see if they work out in the original equation. If I go back and plug in or substitute negative 4 for x, that logarithm of negative 4, when I put that into my calculator, it's going to give me an error because logarithms can only be evaluated for numbers greater than 0 because the domain of a logarithmic function is 0 to infinity. So we cannot use an x value or input that is negative. It has to be greater than 0. So negative 4 is not a solution. And when I go back and plug in 7 for x, I'm going to get log of 7 plus log of 4, because 7 minus 3 is 4, and that should equal log of 28. So I'm going to say that x equals 7 is our only solution. If 7 had turned out to not work in the original equation, then we would say that this logarithmic equation had no solution. But since when we plugged in 7 for x, right here, and both sides equaled out, you would say x equals 7 is your solution. In example 7, guided practice, I would like you to solve the logarithmic equation, this time using natural logs. You're going to have natural log of x plus natural log of 5 minus x is equal to natural log of 6. I would like you to solve this logarithmic equation for x and then choose your solution, either A, B, C, or D, and press submit.